Welcome to One Chemistry. In this video, we are going to see what is Bredt's rule. It is an important concept in organic chemistry. This is very much important while designing mechanism and favorable product. Why Bredt's rule? Suppose you have bridged structure, bicyclocarbon, you have leaving groups bromine and tosylate. You are using thiol as the nucleophile. Where the thiol will attack? The reason is Bredt's rule. Here you should know the bond angle, then only you should master the Bredt's rule. Here CH4 carbon, everybody knows it is sp3 hybridized carbon. The bond angle is 109 degree and 28 degree. That 109 degree comes only if it is a free carbon. If it is in the structure try to increase or reduce the bond angle. That is the basis of Bredt's rule. Suppose you have sp3 hybridized carbon. If you remove the hydride ion, H- elimination, you have cation formation. While forming the cation, hybridization changes from sp3 to sp2, so the bond angle also varies. Tetrahedral bond angle is 109 degree 28 minutes. Trigonal planar, that is sp2 hybridized bond angle is 120 degree. There is 10 degree increase in the bond angle that will demand the structural change. Here I given the Bicyclo compound. There is a chances of forming cation. Problem is the rigid structure because the hybridization changes from sp3 to sp2. It need 120 degree. Because chlorine eliminate mean it eliminated as Cl minus, so cation should form. Cation need 120 degree and planarity. Here cation never forms at all because of non-planar structure. That is Bredt's rule. Carbocation don't form in the rigid carbon. Now we will see the problem. The starting material is bicyclocarbon with two leaving group, bromine and tosylate. You are using thiol nucleophile SH minus can attack two carbon. Before that, the cation has to be formed because two leaving group mean cation form easily, but tosylate leaves mean you have cation at the bridged carbon. So that is what our rule dictates. Cation never form at the bridged carbon. So cation form at bromine carbon, not at tosylate carbon. So major product is bromine replaced by thiol, not tosylate replaced by thiol. So major product is BR substituted by SH. So you should learn the fact that cation don't form at the bridged carbon. Then the next example, the question is stability of cation. B is bicyclo compound with cation. Q is cyclopentenyl cation. R is cyclopropenyl cation. There are three cations, so we should find the stability order. From the Bredt's rule, we can predict that B is least stable because cation cannot form at the bridged carbon. Then R is most stable because it is aromatic, 4n plus 2 pi electron, where n equals 0. Aromatic systems are most stable system. So R is most stable, P is least stable, Q come in the middle. It is a conjugated cation stabilized by double bond. So the stability order is P less than Q less than R. The concept you have to learn here is rigid cation is unstable. Then the next example, the question is on kinetics. Here bicyclic compound is given with alkene and chloride. Water you are using, you are converting chlorine into alcohol through substitution. But you should know why the reaction is slow. The substitution happen via SN1 mechanism. So cation should form. Here cation cannot form because of Bredt's rule. It need 120 degree and planarity, so it won't form. That's why reaction is slow. The concept we outlined here is bridged cation formation. Kinetics is very slow because of unfavorable intermediate. Here you have to find the reaction mechanism SN1 or SN2. The starting material is bridged carbon with chlorine as substitution, OH as the nucleophile. You should find the mechanism based on intermediate stability. Here we can clearly say SN1 mechanism is not favorable because SN1 intermediate is cation. So cation should form at the bridged carbon. As per our Bredt's rule, cation never forms there because of sp2 hybridization. It need 120 degree as well as planarity, so it cannot be S1. It may be SN2 or not because steric effect also plays the role, but our understanding is SN1 mechanism is not favorable.